fisheries research biologist for the Michigan DNR, and behind me is the research vessel Lake Char. Lake Char is another name for lake trout, which is the species of fish that I study. And today you're going to get a glimpse of what it takes to do research on the largest lake on Earth, Lake Superior. Before we go on board and go out on the lake and see what it's like to do research out there, I want to first talk about lake trout. Lake trout is a success story in the Great Lakes in terms of fishery management. It's a keystone predator, and what I mean by keystone is it's an important component of the ecosystem, and when a keystone is removed, it destabilizes the ecosystem. So a little history on lake trout. In the Great Lakes, lake trout is the native top predator. In the 1940s and 1950s, sea lampreys invaded the Great Lakes. It's an eel-like fish that's actually a parasite that digs a hole into the fish and sucks its blood out. It invaded and also had a huge impact on lake trout populations. And at the same time, there was pretty heavy commercial fishing going on that was also depleting lake trout populations. So by the late 1950s, lake trout were extinct from all of the Great Lakes except Lake Superior, and there were some remnant populations left. A lot of effort went into recovering them, and so it's a great success story in Lake Superior because all of the lake trout in the system now are all wild producing. And the research vessel here and the efforts of a lot of other researchers and fisheries managers help restore lake trout. So that's just a quick down and dirty story about the lake trout success story. And today you're going to get a glimpse of what it takes to be a biologist and study in the largest system in the world.
My name's Dan Trainer. I'm a fisheries research technician. I work on the research vessel Lake Char, and I'll give you a quick tour of the boat and just tell you a few facts about it. The Lake Char we've had since 2007 for doing our lake trout surveys. It's 56 feet long, 16 feet wide, and weighs about 27 tons. If you step on the boat, also known as the stern, back here we have this room is called the lazarette. That's where we store our nets, anchors, and the lines we use for setting our nets. We have this hatch, which is the engine room. The forward hatch is called the pump room. That's just where a lot of the mechanical equipment on the boat is, things like water pumps and some of our electrical stuff. Over here we have our lifting table. You'll see later in the video when we're lifting nets, this window opens. This is the gill net lifter. Actually just the roller that goes outside the window. The lifter actually pulls the net on board. The net and fish come on, and then a person stands at the end and puts the nets back in the box. So we lift the fish, lift the nets, pick the fish out here, and then we bring them over here to process, which you'll also see in the video. So we just have our fish boxes where we store the fish, coolers for ice and storing fish, which when we're done processing them, we donate them to charity, such as the Salvation Army or various food banks. This is our processing center, just for our electronics. So we'll keep a laptop here and a printer. This is where we collect all the information from the fish, things like their length, weight, and species. This is the wheelhouse or cabin. So a vessel captain will sit up here and drive the boat using all their electronics. We just have a place to eat or hang out between nets. A little counter for processing biological samples up here. Down in the bow, we have a galley. And then there's another room down below. It's actually the tool room. So that's storage for a lot of electronics and all the tools and stuff we use on the boat.
We're about to set a net.
Okay, go ahead.
We're using bottom gill nets, which is basically a method that's been here for hundreds of years in the Great Lakes.
Sorry.
So a gill net is basically a tennis net you drop on the bottom of the lake to capture fish.
Full set? Is that good?
So the
Okay.
crew members are going to set the nets right now, and we have two boxes. We first deploy the buoys, so you'll see the buoys and cast off the ship. And once it goes off, we're going to drop an anchor, and that holds the net at one end. And then at the other end of the net, we'll drop an anchor, and also in between is the gill net. And the gill net has floats and also leads. So the leads hold the net down, and the floats obviously suspend the gill net. And this is deployed, and then overnight, they're set overnight or a few nights, and then the fish swim by, wedge in, and they're captured, and then we're able to open the nets, as you'll see further in this video segment. Show you how we lift a gill net once it's deployed. So we're going to lift the buoy, bring the anchor lines on board, and then have the net come through the gill net lifter. You'll see the effects of the sea lamprey on lake trout. This is a lake trout with multiple sea lamprey wounds. This penetrates the musculature. This is where it's been sucking the blood out of the animal, and these are other attacks that have occurred. And on this side, so this animal's had multiple attacks. right now we're at the crux of all the work we do on the research vessel. Research team is processing the fish that we collected out of the nets. So we're conducting measurements so that we can look at how the populations are growing, how their condition is, to look at health over time. And we do that by looking at what they're eating, so we're going to extract stomach contents. And then we also age the fish, so you'll be seeing a segment where we extract structures from the fish to determine their ages. So what we're doing out here is the basis of what the Census Bureau does in sampling human populations, looking at the what's called demographics. So how many there are, how long animals live, whether they migrate or move, and then we also look at what they eat, so we can assess if there's any things that are affecting their growth, and so that we can basically look at all these aspects to maintain their sustainability and to report to the managers overall population health. So what he's doing right now is measuring the weight and then the length of the fish and identifying what species it is. And that instrument there is a fat meter, so we're measuring the lipid level so we can look at the condition of the animal, and we can track that over time to make sure that their overall health is stable. So what he's doing right now is looking at what the sex of the animal is and what stage of maturity, and he's extracting the stomach. That would be analyzed later in the laboratory, so we can look at their diet, see what they're eating. What he's doing now is cutting the skull down, and we're going to extract a structure from inside the skull called otoliths. These are also called ear stones, so they're a mineral structure that can be used to age fish. In the laboratory we section these, and you can count the rings in them like inside a jawbreaker or the way they count trees. So those are otoliths, they're small structures, and you have them in your skull too. Showing you is the TV monitor, which actually shows you what's on the computer screen. We're the first research team, I think in the Great Lakes, maybe even in the country, to actually use voice recognition technology to record data. So there's no writing on paper. Everything's recorded through speech, and then it's translated by the software on the computer and then recorded directly into a computer database. So this saves a lot of errors and time, and when conditions are rough, it makes it easier to record stuff, because it's really hard to write when the boat is bouncing all over the place. So what he's extracting here is what's called the maxilla, which we also have on our skull. It's a maxilla bone, and that also can be sectioned, and you can count the rings in those to assess age. Part of our research is to tag fish to study movement, migration, and also their longevity and mortality. So we've got a few larger fish we're going to tag today, and I'll show you how we do that. We use these type of tags. It's kind of like pricing guns at the store. We'll tag it right through the fin rays and then do a twist. and then it locks in, and then hopefully this will be recaptured by our fishermen, and then they'll give us the information on the tag, and we can track where it's gone. Wake up. Lean. Up. Three, 390. Enter. 749. Tag. YX. 6310. Go back. Notes. Release. What I'm doing right now is looking for sea lamprey wounding, and so all the information is being voiced into the computer. So if you look on the screen, undo. Undo. Release. Stop. So it voices in the data. And then once we have all the information, I'm checking on the outside for sea lamprey wounds, which happen often to these fish. So this fish is ready to be released. We're going to put it back in the lake. This fish has a sea lamprey wound right here. Wake up. Next. Lean. Five, 225. Enter. 827. Tag. YX. 6311. Go back. Bravo 1. So this is a sea lamprey wound, but it hasn't really penetrated the musculature, so we classify it as a B1 wound. We categorize them because each one has been studied to see if they're lethal on the fish in the laboratory. And from this information, we're able to assess the damage caused by sea lampreys on the population. Undo. Alpha 4. 1. Back. 0. Alpha 4. 1. Stop.
Well, he took right off and swam away.